If you run Royal Enfield with unit construction engine, this movie is for you. I'm going to share with you how, when and why we should get rid of O2 sensor on the fuel injection system. Basically, if you used to ride a motorcycle with carburetor, you probably enjoyed the quick throttle response and stable idling. And then when you ride a motorcycle with fuel injection system, you may wonder why it reacts differently. It has a poor throttle response. It doesn't have such a stable idling. What you may also wonder is if there is a way to get rid of it, if there is any kind of solution to fix it, to bring it back to the way you got used to it. In case of this Royal Enfield models with unit construction engines, it is a solution that I'm going to share with you today. And this is why I think that everything that follows you may find interesting. I will start step by step explaining a few technicalities with you. I am internal combustion engines engineer, so I will drop you some knowledge too, just to help you to understand why this is in some cases reasonable to get rid of O2 sensor. What is the primary function of O2 sensor in the injection system? I know for sure that this is not obvious to everyone. The key point, the key factor today will be air-fuel ratio. The air-fuel ratio, sometimes called as lambda coefficient. Well, lambda describes deviation from the ideal air-fuel proportion, and ideal proportion is for lambda 1. What does it mean? It means that when lambda is 1, then we have 14.7 kilograms of the air mixed with 1 kilogram of the gasoline. This is the perfect mixture. A perfect mixture means that every single oxygen particle takes part in combustion process, as well as every single particle of the gasoline takes part in combustion process. Look at this diagram. The orange curve represents average pressure, average combustion pressure, which also represents directly torque, a torque that we can measure on the dyno. And as we can see, the maximum torque we can achieve is for lambda 0809, which is for rich mixture. Rich mixture, which means that there is more fuel than it's supposed to be, comparing to the theoretical perfect proportion. Why we have the highest torque, the highest engine performance for lambda 0.8, 0.9 instead of for ideal proportion for lambda 1? To understand this, we need to realize that the highest energy is generated inside combustion chamber only when every single oxygen particle take part in combustion process, not when every single gasoline particle takes part in combustion process, but only when we use all available oxygen that is compressed in the combustion chamber. Only then we can generate the highest energy. And as we know, the mixture is not perfect. It's not perfectly mixed, the air with the fuel. So the only chance to make sure that to make it possible is to add more fuel than is needed. And this is why for rich mixture, which is for 0.8, 0.9, we get the highest torque. Sometimes this mixture is called a dynamic mixture. Okay, so now we understand what is lambda and why we have the highest torque for lambda 0.8, 0.9, which is for rich air-fuel mixture. So we can move on. Next diagram on the top of that one. It shows what engine emits, what kind of exhaust gases ingredients are considered to be danger for human being, for environment, and what we need to reduce in exhaust gases. The red curve represents hydrocarbons, which is unburned fuel. The blue one is nitric oxides, and the brown one is carbon monoxides. All those three curves are crossing each other in the area marked with the letter A. And this area is located exactly for lambda 0.8, 0.9, which is for the highest engine performance, which is for the highest torque. And this is exactly where and how the engines used to be adjusted. The engines with carburetors without catalyst on the exhaust system used to be adjusted for lambda 0.8, 0.9. So we had pretty decent performance, and also we had some kind of compromise when it comes to emission. Now it is time to see the third diagram on the very top of those two. That third diagram represents the efficiency of the catalyst, the efficiency of converting those three ingredients. By the way, this catalyst, we call it three-way catalyst, just because it deals with those three ingredients. So we can see on the top diagram the efficiency, how efficiently the hydrocarbons and carbon monoxides are oxidized, and how efficiently the nitric oxides are reduced. And as we can see, those three curves meet each other in the area marked with letter B, which is exactly for lambda 1. To be exact, it has to be lambda 1 plus minus 0.5%. But of course this is not realistic for the real engine. So this is why the injection system used to keep it lambda 1 plus minus 3%. And this is where the modern engines are being adjusted. Exactly for this area, exactly for this narrow range of lambda values. Lambda 1 plus minus 3%, which is not totally perfect for the economy, what we can see on the blue curve on the bottom diagram, and which is not perfect for the performance, as it shows the orange curve on the bottom diagram. So now we have to take a closer look to the fuel injection system, a modern one. A long story short, the injecting dose, the amount of the fuel that needs to be injected into the inlet pipe, is being calculated by the ECU, electronic control unit. Well, as a matter of fact, it is not a calculations as such. It is because it doesn't calculate anything. The ECU doesn't calculate anything. We need to imagine that it works like a multi-dimensional table, you know. So it is like we have several inputs, and for those inputs we have preset outputs. So this output goes as a signal for the injector. Just simplifying the story, and this has to be proceed very quickly. So the ECU has to be able to react to change the injection dose from one working cycle to another. And sometimes it is like a 50 times per second, 50 working cycles per second. So it has to work really quickly. There is 3 necessary signals on the input side, which is one of the most important, map sensor. Second one is TPS, and the third one is RPMs. So these 3 signals are absolutely necessary and absolutely sufficient to make the injection system work properly. But then, of course, engineers has to consider the highest efficiency of the catalyst. And this happens when the lambda is kept strictly around 1, plus minus 3%. And this is why the O2 sensor is needed. So lambda sensor measures the amount of the oxygen in the exhaust gases. And that signal is given to the ECU as a feedback. So based on that, when the engine works under stable conditions, when we do not accelerate, when we do not decelerate, when the engine is not idling, then the ECU tries to optimize lambda coefficient to get as close to 1 as is possible. And that is the only function of the O2 sensor, of the oxygen sensor in the injection system. I know that some people think that without oxygen sensor, ECU wouldn't be able to calculate, to estimate the injecting dose. This is not true. Lambda sensor doesn't serve for that purpose. Okay, now armed with the knowledge I presented, we can go back to Royal Enfield, which is, as a matter of fact, main topic for this movie. This is my Royal Enfield. I bought it brand new back in 2014. As you can see, I don't have catalyst on the exhaust pipe. This was replaced by the dealer. I just didn't like the original muffler, the gigantic RPG. So without catalytic converter, please have a look at this diagram once again, the top one. If we have no catalyst in the exhaust system, then the emission is even worse because we emit much more nitric oxides. So even for the ecology, would be better if we went back to the lambda 0809, the area that the engines used to be adjusted to without catalyst. So this, combined with those negative feelings from poor throttle response, made me wonder if there is any solutions. And one day I've seen on the YouTube this movie. It is a movie where a guy in India presents his motorcycle, so he goes around with the camera showing the motorcycle around. And at some point I was surprised. Look at this. This is EFI model with fuel injection, of course. And when he goes around with the camera, when he shows the exhaust pipe, we don't see there any oxygen sensor. And I was like, wait a minute, this is fuel injection system. So where is the oxygen sensor? And then digging deeper into this subject, I finally found out that there was an original fuel injection system for domestic market that worked with open loop without oxygen sensor. Because there was no catalyst on the exhaust pipe. If there is no catalyst, there is no point of creating or building injection system working with closed loop with oxygen sensor. So my next question was, is it really adjusted then in such instance to the area marked here with letter A for lambda 0809? That had to be verified. And then going deeper to the details, I found out that the injection system itself is exactly identical. The one for domestic market with the one for European market, for instance. So there is no differences in any kind of components. The only difference is the ECU. And of course the ECU is also looking identical. And it also has the same part number, the one for Euro 3 and the one for domestic market. So it was a challenge to be able to recognize them. I'm telling you this just to make you realize how complicated it was. At least it was complicated to me. So at the end of the day, I just realized that there is a small sticker on the left top corner, and that little number on the top of the sticker, it tells us about the kind of software inside the ECU. And this number on the sticker with the sign domestic, it describes the software that is able to work without O2 sensor. Here I combined all those recognition I've done in this table. So next stage was to purchase those ECUs and just check them out. And this is what I've done. I bought 2 of them for me and for a friend of mine. So one day finally I got 2 of them and we installed them, me and a friend of mine. Here comes one tip: when you replace the ECU, it is very advisable to disconnect the battery completely, then just to unplug the ECU, to plug the new one, and then to hook up the battery again. And of course I disconnected the O2 sensor connector. First difference: during the cold start of the engine, the idling is much more stable than on the Euro 3 ECU. It is so much stable to the extent that you don't even need to use the choke lever on the handlebar. Very pleasant feature. I really enjoyed that. Then the first ride. The acceleration is noticeably better. The throttle response is literally like on the carburetor. It basically feels like you have electronically controlled carburetor on your motorcycle. So the reaction is really sudden and really dynamic. Another friend of mine decided to verify it more precisely. So he installed in the exhaust pipe a wide range of O2 sensor hooked up to the reading device. And he confirmed that during acceleration the mixture goes really richer than comparing to the Euro 3 ECU. So we know for sure that it goes richer. If it goes richer, the next question is the fuel consumption. To be honest, we have not noticed any difference in fuel consumption comparing to Euro 3. Basically, important information: you can go down to domestic ECU, we call it Euro 0, only when you have Euro 3 ECU on board. If you have Euro 4, the small one, that wouldn't be possible because the connector is different. Connector is not compatible. So since this was verified and a friend of mine had even more enthusiastic conclusions, there was several other friends that wanted to check this out. We got those ECUs for them as well, and they were also very positively surprised, enjoying stable idling, enjoying nice acceleration, and enjoying throttle response. I share this information with you because if you also bother with all those negative engine behaving caused, as it turned out, by O2 sensor, then at some point you may want to get one of these and check this out. Any negativities? I wouldn't see any so far. This is a really clean solution. This is fully original solution. This is literally plug and play solution. So far no negativities whatsoever. I guess that would be all for today. And of course you expect probably to hear now something like please subscribe or something like this. I think that in this particular case it wouldn't be necessary, or it would be even pointless. First of all, most of my movies are in Polish because I'm Polish. Second of all, as you can see, I don't allow any adverts in my movies, so I don't make any money on this YouTube channel. Anyway, I hope you find these informations useful. If not useful, maybe at least interesting. Take care. A few important tips and notes on the end. Of course, making this downgrade from Euro 3 to Euro 0 or to domestic version, we have to realize that it can have potentially a legal impact. So please consider that, because you take full responsibility for it. The question that I hear very often is it possible just to unplug the O2 sensor? Then the ECU would work with in open loop, right? No. Well, it will in a way, but it wouldn't be the way we expect it. It would go to the special working mode, just protecting the catalyst. So the engine performance would be much worse, and we will see the engine warning light being displayed on the dashboard. So no, unplugging or cutting off the O2 sensor is not the way we should go. It has to be done more smart way. So now the movie is over for sure.